Jag tycker det är så ödmjuk start på dagen. Det känns verkligen, förr i tiden fick vi applåder, nu är det så här, kan de inte sluta liksom. Nu räcker det. Vi fattar. Välkomna till den här summiten. Jättekul att se så många här. Jag får en hel del tankar när jag ser så mycket människor. Vi ska prata mer om det sen. För att, vi har hållit på faktiskt i 10 år. Och vi kommer göra någon liten minifirande här då också på grund av det. Just vi i Trusex som ni har anmält er till för summiten en dag. Och jag kommer också ihåg en av de första framträdandena jag gjorde på nya jobbet när vi, i början på Trusex. Jag fick sitta på något frukostseminarium på Berns. Och så var det massa såna här IT-chefer och grejer. Jag var ren pentester så jag tyckte de var rätt jobbiga och tråkiga så här. Nu är jag typ så här kavajer själv. Men då kände jag verkligen att de var gubbar. Typ lika gamla som jag idag. Men hur som helst kommer jag ihåg för att de stod där och visade liksom på internet hur säkert det var. Det var liksom många av de som varit med och byggt internet som stod i panelen. Och jag sa, det är inte alls säkert, det går att hacka vad som helst. Liksom. Det är jättedåligt. För vi gjorde ju pentester och det var inte så bra. Och vi ska prata idag om hur det ser ut idag. Då. Men då sa någon, jag tror det var Patrik Fältström eller någon sån där kändis, som bara, liksom, du bara snackar. Och liksom, om det är så dåligt, varför händer det inte mer då? Liksom. Och mitt enda svar det var från hjärtat som jag kände. Ondskan har inte mognat än. Och ibland är det så skönt att få rätt. För nu har ondskan börjat mogna. Och det är väl lite det som vi vill förmedla här idag. Att det faktiskt är så. Och jag kommer börja den där keynoten med lite enkel fakta och data och sådana saker. Sen kommer vi svänga över och göra coola live-demonstrationer resten av dagen. Men det är ganska mycket som händer. Och tittar man lite snabbt på bara top 10 predictions. Det här är från McAfee Intel. Men jag tycker det stämmer rätt bra. Cyber warfare blir någonting legitimt. Alltså, stater börjar tycka att det är okej med cyber warfare. De ursäktas inte längre när man kommer på deras kampanjer. De enforcar sånt för att kunna genomföra sin myndighetsverksamhet. Man jobbar med att få övervaka både medborgare och folk i andra länder. Och det blir en del av den naturliga processen. Det är någonting nytt. Vi har aldrig haft så mycket myndighetsfolk sittandes här idag som vi har nu. Även ifrån de myndigheter som jobbar med sånt här. De är här i publiken idag. Det är för att de är intresserade av det här. Det är viktigt. Det är någonting stort. Så det är så. Active government intervention. Myndigheter å andra sidan också hjälper till mycket mer när det blir avancerade dataintrång idag. För ett par år sedan så stod man själv om man var ett stort företag och blev drabbad av intrång. Idag kliver myndigheter in, polismyndigheter och sånt, och verkligen hjälper till med utredningar och sådana saker. De är tvungna. Nu pratar jag inte om Sverige generellt, jag pratar om världen. Trenden går åt det hållet att man känner att det är samhällskritiskt med de här dataintrången så man måste gå in och hjälpa till, annars förlorar landet sin konkurrenskraft. Samhällssystemet fungerar sämre. Det är ungefär som sjukvård och sådana saker. Det blir saker man måste ha stöd från samhällsapparaten. Det är någonting som är nytt. För er som är intresserade av att jobba med säkerhetsfrågor, alla ni är intresserade av säkerhet, så är det är ett jätteunderskott på säkerhetskompetens i världen idag. Det är definitivt en växande karriärsväg och det skapas hela karriärsvägar inom IT-säkerhet och cybersecurity. Man har ju valt länge mellan vilket ord man ska ha. Cybersecurity, om det är töntigt eller coolt, eller hur? Det är rätt svårt att veta. Nu har Microsoft officiellt döpt det till cybersecurity, så då blir det väl så. Vad man än tycker om Microsoft. De stora vassa attackerna mot högprofilmål kommer att fortsätta. Det är 2 stycken olika typer av högprofilmål som kommer att drabbas. Dels de som har riktigt dålig säkerhet som kommer att åka dit bara därför. Och dels de som har väldigt intressanta saker. De kommer att drabbas. Så enkelt är det. Men 4 av 5 storföretag har haft dataintrång. Och antalet intrång på den nivån ökade med 40% förra året. Det betyder inte att alla haft 2 intrång direkt, men det betyder att det blir fler och fler. Attacker blir personliga, man ger sig på individer och det är faktiskt både från samhällsfunktioner, du pratar inte generellt om Sverige, men att myndigheter börjar övervaka individer, man börjar trycka igenom lagar för att få rätt att installera trojaner som bugging och sådana saker. Det är nya trender, sånt som händer. Kryptolocker och sådana saker har vi sett en hel del och kommer prata mer om det. Sånt blir mycket vanligare, att det drabbar dig som individ. På storföretagen är det också en förändring, eller på företag överhuvudtaget. CIOer, CSOer och sådana blir ansvariga för säkerhet. Så när saker inte funkar så riskerar de sina jobb i princip. Det har blivit en ledningsfråga. Det är något nytt. Det finns några kända uttryck från några viktiga vd:ar som säger oj, vi har tydligen fått dataintrång, men jag ska iväg i helgen. Kan vi ta det på måndag? Den tiden är över. Hoten blir allvarligare. Malware och angreppen blir mer avancerade. Jag kommer att prata lite grann om det också. De följer utvecklingen. Så när det blir ny avancerad infrastruktur så tar de sig in och förstår och lär sig den också så de kan bryta sig in i den. Och när man säger en sista, cybersecurity attacks evolve into something ugly. Det betyder att vi kommer se en värld där man jobbar mer sofistikerat med att faktiskt manipulera information, sätta sig i viktiga system och äga och kompromettera dem. Typ kriminella organisationer kommer äga banksystem och börja manipulera dem på riktigt. Ondskan håller på att mognar. Muntert, va? Så lite fakta, bara så man förstår världen som händer. Attackytan, det attack surface i världen håller på att förändras. Vi kommer att ha 1 miljard till användare på internet inom några år. 4 miljarder användare av internet. Vi kommer öka med över 1 miljard nya smartphones kommer komma närmsta åren. Anslutna till internet. Förr i tiden hade alla laptops i publiken, nu sitter de flesta med bara en smartphone. På sådana här events. Ni har inte ens mer en laptop längre. Datavolymer, IP-anslutna devices med Internet of Things och så, de ökar enormt. Och allt det här ställer nya krav. Och det gör också att väldigt mycket maskiner kommer på nätet som kanske inte hinner genomgå avancerade säkerhetsprocesser för det är så snabbt som det här ska explodera. Här är ett exempel från Dell. Alla nya Dell-laptops och desktops som har släppts från augusti i år har ett rotcert som någon litar på. Problemet är att Dell har skeppat med den privata nyckeln till det rotcertet. Så att i alla Dell-laptops ligger nyckeln som gör att man kan avlyssna alla andra Dell-laptops utan att upptäckas. Du kan se man-in-the-middle-attacker på alla Dell-laptops. När du frågar om varför de gjorde så här så var det för att underlätta supporten. Och det gör man ju. Man kan ju gå in i vilket trafikflöde som helst och kolla. Man stör ju inte användaren på något sätt. Det är jättebra. Men det här är någonting som vi inte bara ser i Dell-laptops. Det är slående för många av er kanske har sådana. Men i nya devices och interaktioner med internet och myndigheters önskan att få övervaka och sådana saker så är det här väldigt smakligt. Nu säger inte jag att det är så i Dell-fallet. De är naturligtvis helt oskyldiga. Men sånt här dyker upp överallt. Och det är intressant. Det finns en länk där om man vill veta om man är sårbar. Så har ni en Dell-laptop från augusti i år så är det förmodligen det. Det är en vapenkapprustning med cybervapen för stater. Varför är det intressant? Ja, det kanske inte är så intressant tycker man initialt om man inte jobbar med en statlig myndighet som håller på med sånt. Men det finns 29 länder i världen idag som aktivt har team och en kapacitet att utföra cyberkrig. Alla de är inte våra vänner. Det finns 49 länder som faktiskt handlar den kapaciteten som inte riktigt har den själva. Och ännu fler länder som använder det för intern övervakning. Anledningen för var och en att det här är intressant är att det är skillnad på konventionella vapen och cybervapen. Det är så att om man bygger en väldigt avancerad atombomb så är det inte så lätt om man bara lägger den i ett rum eller man skeppar den någonstans att alla kan kopiera den. Men när du släpper lös ett cybervapen, en avancerad övervakningsprogramvara eller en zero-day-attack eller någonting. Så fort som den kommer ut på nätet så är den exponerad. Och i många fall faller det här i orätta händer. Och det kan kopieras på ett helt annat sätt så det är ingen kostnad alls. Så vi ser ju väldigt ofta hur attackkod kommer ut på nätet och klonas och förändras och kan användas av den kriminella världen trots att den från början kanske byggdes som cybervapen. Stuxnet, Duku, massa sådana här exempel, Flamer. Alla de teknikerna har funnits senare i attacker hos kriminella. Så man säger det inom försvarsmakten, ska du bygga ett cybervapen måste du bygga ett antidote också, för det kommer att komma ut så småningom. Så du ska skydda dig mot ditt eget vapen. Sånt man inte tänker på. Attackerna generellt blir mer sofistikerade. Vi ser redan nu, och det här är sånt som vi faktiskt tillämpar när vi är pentester också. Man börjar att skapa firmware-kod och sånt så man kan överleva till och med en wipning av hela operativsystemet. Så att vill man vara persistent idag så lägger man sig till och med på hårdvarubotektorer och sådana saker. Fillösa attacker, alltså man angriper minne direkt. Man lägger inte ner någon malware i form av en exe-fil på disken. Sånt faciliteras av PowerShell och sådana saker. Så man kan köra rakt in i minnet ganska enkelt idag. Det finns färdiga skript på nätet. Man exploaterar remote access, alltså terminaltjänster och sådana saker i större omfattning. PowerShell, VMI för er som är tekniker. Man behöver liksom system som kan remota, så det här blir allt vanligare i och med att man ska kunna ha tjänster i molnet och remota dem på ett smart sätt. Angriparna använder den vanliga remote-funktionaliteten istället för att installera trojaner. Det ska man ha klart för sig också, det är en ny trend. Man krypterar trafiken. Fabio kommer visa ett exempel på hur man tunnlar med DNS-trafik, men innehållet är krypterat, så det är svårt att förstå vad det är för någonting. En till trend är så kallad sandbox evasion malware. Att man kommer att ha ett helt annat tålamod idag. Man kan installera skadlig kod på en dator och sen vänta i 2 månader innan man gör någonting. Så man lägger ut sådana otroligt stora angrepp på så många mål så man kan vänta och sen skörda lite som det känns. Och då blir det väldigt svårt att upptäcka det för att man har sandbox-tekniker som ska kolla efter beteenden. Förr eller senare måste man släppa binären och säga att den här är okej. Det finns exempel på sådana här hårdvaruproblematik. Det är till exempel att hacking team, som säkert många har talat om, som sålde övervakningsprogramvaror till myndigheter i olika länder. De blev hackade själva. All deras kod hamnar på internet. De hade såna här UEFI rootkits. Väldigt avancerade saker för att installera sitt system. Men nu finns det på nätet med källkod och allt. Så nu kan ni själva bygga ett sånt. Eller modifiera ett befintligt. Så det här är den nya världen. Det sprids som 17. Equation Group är någonting statsfinansierat. Där har man också haft avancerade kunskaper i hårddisk firmware. Som kunde planteras och överleva rensning av hårddiskar genom att bo kvar i hårddiskarnas firmware. Det kräver ganska avancerade kunskaper, men när det väl är ute så hittar man det i en firmware. Då kan man kopiera det. Sånt finns ute idag. Zero-day-attacker fortsätter. En trend som vi ser är att det tar aldrig slut med Adobe Flash och Adobe Reader. Det är ett fantastiskt säkert sätt att bli infekterad och fortsätta köra de här plattformarna. Det är otroligt framgångsrikt faktiskt. Man känner att man skulle vilja ha hjälp med fjärrstyrning av sin dator. Men det är många som försöker sig på HTML5 och sådana saker. Men adoptionen till de teknikerna från det gamla, det går jättelångsamt. Med Flash och sådana saker. Man tittar på en global basis. En sak som vi har sett väldigt mycket i Sverige, det är lustigt för läser man alla sådana här threat reports så pratar man inte så mycket om Sverige. Sverige är underrepresenterat. Men vi på mitt företag, vi har gjort väldigt många sådana här crypto wall och crypto locker utredningar sista tiden. Det är väldigt många av er som blir drabbade. Och här är som ett exempel är bara en screen dump hur det ser ut. Man får en svart skärm och så får man upp en liten sån där det står så här gör du för att skapa en bitcoin wallet. Så här tankar du din bitcoin wallet och så här pröjsar du till oss. Och det kanske inte låter så väldigt farligt. Det finns lite statistik på hur stora de här är. Men det är 100,000-tals infekterade datorer i världen. Och när Intel och några andra tillsammans har gjort en utredning och följt pengarna i de här bitcoin-walletarna så har man hittat i alla fall en master wallet som det låg 235 miljoner US-dollar i. Det är ganska mycket pengar. Eller så mycket transaktioner gick till samma aktör i alla fall. Om det var en eller flera master wallet låter jag osagt komma på. Men allting börjar med phishing-e-mail eller URL som man klickar på. Sen så kommer man till en sida som man får upp på sin skärm. Man blir redirectad till en payment site. Och där ligger en massa små walletar. Och de i sin tur flödar till samma master wallet. En intressant sak som man ser är att flera olika kryptolocker-varianter, även med helt andra namn, går ofta till samma master wallet. Så det verkar som att det finns några väldigt slipade hjärnor bakom allt det här. Som har flera olika typer av kryptolocker-varianter ute. Det som vi ser som ett problem, det är när du får in kryptolocker i din dator och du har en jobbdator. När du har en G-drive eller något sånt där som alla anställda får skriva till. Vi gör många sådana utredningar. Det är terabytes och terabytes av data som krypteras. Och verksamheten stannar. Så det är någonting man måste förstå. En intressant sak också är att de flesta av de här attackerna nu för tiden börjar bli så pass sofistikerade så att man får ett mejl av en kollega skrivet på svenska, ser schysst ut med ett Word-dokument i. Word-dokumentet har ett makro eller en zero day. Det är en ganska vanlig vektor idag. Här i Sverige. Det är svårt att skydda sig mot. Det finns inte en svart låda som fixar det. Utbildning är bättre i sådana fall. Konfiguration. En annan intressant sak. De här kryptovål-varianterna idag, version 4 och de här version 3, de faktiskt tar bort shadow copies och sådana grejer. Så de ser till att det inte ska gå att göra recovery på disken. För bara en stund sedan så gick det att göra lite schyssta återställningskommando. Men nu finns det några sådana här delete shadow copies, funktioner i dem. Man förutspår att OS X kommer att åka på stryk nästa år och få sina första kryptolocker-varianter. Det tycker jag är lite rättvist på något sätt. Skämt åsido, det har att göra med att det är en populär plattform. Man slår ju där man tror att man kan få betalt. Så enkelt är det. Men den här ekonomin, den närs ju. De får så mycket pengar så de kan anställa lite duktiga Mac-programmerare också. Det är så enkelt. En annan sak som man förutspår, det är on-the-fly-kryptering. Att man lägger in kernel-komponenter och sånt där så att man ser vilka dokument som du är intresserad av och krypterar bara dem. Och även får upp information om dem. Men som sagt, det blir fler och fler attacker som hamnar uppe i styrelserummen. Och fler riktade attacker som faktiskt gör skada. Och jag kommer hoppa över till engelska nu. Because me and Fabio are going to illustrate one of those attacks during live demos. So this is like the first session after the keynote. There's going to be flawless flow over to that session. So Fabio, if you want, you can actually get ready and I'll explain this.
Yes.
I hate the fact that I need to speak English in front of all the Swedes, but otherwise Fabio won't understand when it's his cue. Yeah, you're learning, right?
Yeah.
Can you speak some Swedish?
Next time.
Yeah. Lots of self-confidence there, my brother. Anyhow, there are two different main attack vectors, of course. I mean, we've been talking about this before. There are the client-side attacks, which are actually the most common today. But we're going to do a demonstration of one internet-facing web service attack. And the reason we're going to do this is because there's so much focus on client-side attacks nowadays, we're kind of forgetting the server-side ones. So another thing that we realize is the fact that so many of you guys focus on the OWASP top 10. There is like penetration testing, check for OWASP top 10. Security assessments, check for OWASP top 10. Vulnerability scanning, OWASP top 10. So just as an example, we're going to show you something that is not on the OWASP top 10. Because I think that's important. Because sooner or later it's just about compliancy. Well, you want to find the vulnerabilities that can compromise your internet-facing websites. So we're going to talk about another example, which is merely an example. It could, of course, be one of the OWASP top 10, like SQL injection and stuff. But this is one example of the things that we not very rarely find in the wild. And in order for you guys to understand what it is, because it's an XXE problem, Fabio is going to explain XXE on a technical level. And if you're not programmers, it's okay. Just look at this as if you're watching Discovery. It's fine. Like, you know what it is. You don't have to reproduce it. But again, I want to open your mind to, well, there can be other things out there that I don't think about if I only go for mainstream, like OWASP top 10. Okay? And then we're going to see what we can do with this. So, Fabio.
Yes.
Take it away.
All right. Thank you, Marcus. So, XXE, one example out of the OWASP top 10, but still very common. How many of you have heard of XXE before? XML external entity attacks. Just a few. We're going to give a little context, just to put things in perspective.
So at least 300 minus 3 guys will learn something new in this session. It's good.
All right, XXE. So it has to do with parsing XML files. So basically, if you parse an XML file that is submitted by a user, you are potentially vulnerable to this type of problem. And well, XML is pretty much everywhere nowadays. So we need to cover a couple of basic things. So 2 more minutes of boring stuff, then we get to the demo. XML. You all know what XML is. It's a markup language we use to store and transfer data. And it's multi-platform. XML files can have document type definitions. So that is basically what defines the building blocks of an XML document. So whatever is going to be in that XML document can be defined in a DTD.
Yeah, the schema, so to speak.
Yes. So elements. You can define elements, which are basically the blocks of your XML document, and you define those in your DTD. So this is what it can look like. Take the example on the left. The yellow part, starting with doc type, that's the DTD, that's the document type definition. So that's where we define, for example, the elements that will be in the XML document, which is the green part here. So that defines elements such as person, name, and so on, which we'll then use in our XML document. And if you take the example on the right, you can do the same thing by referencing to an external DTD file. In this case, that example.dtd, that contains the same thing that is on the left, but it's stored in a separate file. So far, nothing special, right? We have entities. Entities are basically some kind of variables or macros. You can see them like that. Roughly divided in internal and external. There are different combinations, but an internal entity is basically a definition of a text that goes into a variable. You can see it like that. What we're interested in are external entities, which we define with URIs. So we can reference to an entity which is located on a different location than the XML parser. So in the example there, we have an external entity named ext2, which will load a DTD file from an external location that we specify with the URL there. OK? Good. So an XXE attack, an XML external entity attack. If an attacker controls the XML document, they might also be able to control the DTD inside the document. If that's possible, and if it's also possible to specify arbitrary entities in that DTD, then we can trigger the XML parser, thus the application, to make a request to an arbitrary location that we specify in the DTD as an external entity. If we can do that, we can either reference to local files on that system, and we can possibly read files from that system, or we can trigger the system to connect to another system. So that's what we call a server-side request forgery.
So potentially, if you are on the internet and you're targeting a web server that has this vulnerability, then you can potentially read files on internal servers. You can potentially read local files on that system. We're going to show you what you can do with that. So this can be a way into the network, using that web server as a, if you will, proxy or router.
Yes. So, demo time, finally.
Yay.
Yay. So, a very simple application as an example. We have a page displaying logs. And we have a page where you can test your logs. You have a simple table. When you click a certain cell, this will be logged, and you see, oh, this cell has been clicked. Very useless, but just an example. So I'm going to use a local proxy, burp suite. This will basically be in between my browser on my machine and the remote server, and it will pass by all the request and response, HTTP request and response going by.
Yeah,
so I can see exactly what's happening.
The idea is to investigate and manipulate your own traffic, basically.
Yes,
yeah.
So you're not limited by the browser, basically. Right, so what happens when you click a cell? If you look in your proxy, what's happening behind the scenes, your browser is making a post request, and this will be the content, which I had pasted here so it's more readable. So this is what your browser will post to the server in order to log that operation. So we specify basically the data that will be logged. That's what we see in the table here. All right? So that's XML. So if I see that I'm sending XML, I think about XXE. So I'm going to send this to a module in this tool called repeater, which will basically take the same request. You can edit it and send it again. And I'm going to change the data just to see if this actually works the way I expect it to. So I'm going to write like test and send in this request. Application responds with a simple OK. So I can refresh that page, and I see I have my test here. So I can affect that simply by changing the data in that XML element. So if I can define my own DTD, then it would look something like this. I need to define the elements that should be there, the ones that were originally there. So application and data were in the first request. So they need to be there because the application expects those elements to be there. And then we can define an entity in our DTD. In this case, we try an internal entity. We just assign some text to the entity, and we print it out here in the data. That's where we wrote test before. So this is the same thing, just without new lines. So if I take this and I send it to my server, I can reload the page, and I can see I have my text here. So defining entity works. So now I need to try if I can define external entities. And I can do that by starting to accessing local files. So instead of just writing text here, I write file, and I specify a local path to that file. I take this, send it over here. I get an error back from the application that says, sorry, I couldn't find file c:/test, which is great. This means that the application is actually trying to access that file. So now I just need to find files that exist. What's the file that exists? I can take win.ini in the Windows folder. That is often there. Go. Now we got an OK back, which is a good sign. Now we can reload the page, and we actually see the content of that file that is printed out here. So we can reference to an external entity, which in this case is a local file in that system. The content is going to be assigned to an entity, and then we can print it out and see the content of the file.
So what files would you go for? We're just a small bunch of friends here. We can speak out loud. It's fine. Well, it could be, for example, web config files or things like that that could contain maybe SQL connection strings with username, password, stuff like that, right? For example.
Yes. So a web config file would be nice to check. So what would we do? Well, we could assume the default path of this application. Otherwise, we can do some guessing or brute forcing. But I have the feeling we're going to be lucky.
Yeah. It usually happens in our demo environments. I don't know why. It's like
So let's try to access the web config. See what happens. We got an error. It says configuration element is not declared. Now, the configuration element is part of the web config file. The web config file is an XML file. If we put it as an entity inside the DTD, that will break the DTD. We can't have XML in there. I mean, there's going to be, it's not going to work. It's not defined like that. So that's one problem we have. We can't really read files that will break the DTD. And we're also relying on the fact that the application is printing out the data that we send. And that's how we could read the content of the file, which is a very fortunate situation, very demo-friendly, but not always the case.
Yeah, so normally we would work with something that is called a blind XXE.
Yes, so there are a couple different tricks to make this work and solve both these problems. I'm going to show you one of them. Which will work like this. We send the custom DTD, as we did now, and we access a file on the system. But then in that DTD, we also reference to an external DTD, which will be hosted on our attacker machine, something called evil.ddd, just not to draw any attention. That DTD will contain an additional reference, again, to the attacker web server by passing the content of the file as a get parameter in the URL. Right?
So if this is too complicated, just nod your head and believe that Fabio is a cool guy. That's basically it.
All right, so the attack will look like this. This is what we're doing. We are referencing to the web config file. This is this part over here. Then we reference to another DTD on our machine. The 188 is the machine where I'm attacking from. And we load the evil.dtd. Now, the content of evil.dtd will be this. So once it's loaded, that will trigger the server once again to make a call to our server, and it will pass the content of the file in the URL. And the file is defined here as an entity, and will contain the content of the file.
So we're basically cleaning this up in order to be able to read it. Using some Italian magic.
Now, if this works, where would that end up? In the web server logs, right? In this case, we make a get request with the content of the file. So I have a server running here. I can check the access to the server. Now I have some gets. So let's send this. Now, we get an error, but we don't really care. As long as we get to this part, then we don't really care if the parser is failing. So we go back to the logs. Now we have a new log. And the content of that get parameter will be what? Will be the content of the web.config in a URL encoded format. So we just need to URL decode it. We have a tool in Burp to do this. Decoder, decode as URL. And there's the content of your XML file, web.config, including connection strings, in this very fortunate case.
Can you zoom in maybe?
Not from this interface, but I can do this.
Yeah, we just want to make it visible so that you guys
Yes.
in the back can see this, but you can highlight there and say that you have the username and password of the database, for example. So this is a typical technique that you can use. And all it takes is a little bit more skills than the average script kiddie, to be honest. And whenever there's a good YouTube video out there showing this, then other people can start doing it as well. That's the nature of cyber weapons, if you will. So, what can we do with this, Fabio? Can we make it worse?
We can make it much worse.
Oh, really?
So, we are accessing almost arbitrary files to that system. Almost any file now we can read and exfiltrate. So what do we want to do next? Well, as I mentioned, we can not only read files on that system, but we can trigger the system to make other connections to other systems, potentially internal systems. So if we use our XXC attack to do that, and the XXC server, or well, the vulnerable server, will be most likely in some kind of DMZ segment, and it will have access to other resources that we can't reach directly, right? But we can make it reach it for us. How do we figure out what's behind there and what we can access? Well, we try. So let's try. So I can not only specify an IP, but I can specify a port too, right? That will trigger a web request to that server on that port. So can we try to browse to this IP, for example, this internal IP on port 445, SMB? We can try. We get an error back saying error opening entity. The underlying connection was closed. So what does this tell us? Well, it tells us there is something on the other side that is responding something that we don't expect. Well, that's probably an SMB service, and we're sending a web request to it, so no surprise there. But we know that the service is there and it's responding. So we know that port is open on that system. If we do the same on another IP that doesn't have the SMB port open, .2 for example, click go. This will take quite a long time, eventually time out, and say I can't connect to that port because there's nothing responding there. So if I script this, I scan all the
ports on various target systems.
Yes, thank you.
Then you will know which one has the listening port and which one hasn't. So you can actually use this as a port scanner internally by sitting on the internet, going through that XXC vulnerable web server. So what would you target internally if you can do this? Obviously, you can only send web requests. So it would be natural to start targeting internal web servers. And do you think that internal web servers are always as hardened as external ones? No, it's pretty common if you do an internal pen test that you find vulnerable, weak web applications because nobody really cared about securing them that much because they're sitting internally as opposed to something that is sitting on the DMZ. So that is the natural next step if you have this kind of vulnerability.
So let's try to browse internal web servers.
If this wasn't such a corporate event, I would say, hell yeah!
So we have an application internally, and we can reach through the XXC to a web server named internal demo.com. So we can use the same technique that we use to read local files, but now we specify an internal web server. So what's going to happen? Now we trigger the target server to make a request to the internal web server. What would the response be? Well, what before was the content of the file, now it's going to be the HTTP response from the internal web server. And once again, we can read that from our log file. We have a new entry here.
But it's not a really nice browser, is it? Not the way you want to browse web servers.
No. So how do we make it better? Well, we basically automate the whole thing. Send in an XXC to a certain resource, get in the response in the log, take the log, URL decoded. If we make it transparent, we just write our own script that does that, then we can have a nice browsing experience. So I did something like that. Took a Python proxy, a local proxy, and I added a plugin to it. So the plugin will basically change the HTTP request and response going by. So very briefly, it will look something like this. This is the function that takes a request from our client, from our browser, and sends it over to the server. Instead of sending it directly to the internal server, which we can't reach, it will send it to the external server, the one vulnerable to XXC, and it will change the request body with the XXC attack, and the payload would be the host that we were trying to reach in the first place. Now, when the response comes back, instead of giving that back, which will be just the XML error that we saw before, it will swap that with the content of the file read, sorry, the content of the HTTP response read from the log file. So it will be done transparently. We don't see it, but the effect will look something like this. So we start the local proxy. We set the browser to use that proxy, and we browse to internal.demo.com. Now the proxy will do all that work for us, and we will transparently browse to internal applications.
Yeah. So realize it's now sitting on the internet, talking to that external XXC vulnerable server, and is browsing internal sites. And there's nothing strange about it. I mean, and this is, again, is something that would be very hard to do if you don't know what you're doing. So most vulnerability scanners and stuff would miss this. And if you don't have an internal vulnerable websites, it's not necessarily a big problem. But again, how do you know? So these are the kind of attacks that you will normally find when you have an advanced attacker in front of you, or you do real pen testing or something when people are skilled. There's a big difference when it comes to knowledge on how vulnerable you may be. So
now we're browsing internal web servers. And we will try to find the most vulnerable internal web server that we can exploit, potentially jump to it. So if we continue our scanning exercise, we will eventually come across all the web servers internally. And we might find something like this. An internal admin interface, a web admin interface to, in this case, a JBoss server, web server.
And this is a very good example because it's so damn common still.
Yes. It's internal. It's the internal admin interface. It's often exposed if you're internal. So you can just plug your computer to the network, reach the administrative interface, and administer that system. In this case, it's web server. So we can run administrative commands on a web server, or at least web request to that web interface. So what do we want to do? If we can manage the web server, we can try to deploy a web application on it. And web applications can run code on the server. So we will step to code execution attack. So I'm going to fast forward this part. I'm going to show you the result.
And we can show them what the console looks like where you find it. Maybe.
Yes. Well, if you have that type of interface, you can send a GET request like this to the JMX console in this JBoss admin interface that is exposed here. One of the many functions, you can invoke it like this, and you can specify a application to upload and deploy. In this case, it will be something in web shell or with some JSP code that you specify. And the JSP code will be something like this. It's a very, very simple page or JSP file that will take input from the user and use it to execute commands on the system and display back the result. So that's what we call a web shell. So doing some rewriting and encoding and some magic and some WRL encoding, because we're posting this to an XXC server that will post to an internal server. So it's a couple of steps we need to take care of. But then eventually our XXC attack will look something like this. This will just be exactly as before, except the entity will be that GET request deploying the JSP shell on the internal JBoss server. Now, if this works, it will deploy web shell.
So it's kind of funny. We're still sitting on the internet, sending this text mass to this vulnerable XXC server, and an application will be deployed on an internal server.
So if this works, we should be able to browse to web shell. Let's see if I call it like that. I don't have it here. I have it here. So if this works, we should be able to call the web shell that we just deployed and run commands specified here, like who am I, for example. If we try to do it, now the application is not there, so the XXC server, the vulnerable external server, will say that it can't connect to the internal site because it's not there. If we send the attack or the payload, we try to reload this page. Now we're executing commands on internal JBoss server.
So this is a typical initial breach where you go from a small flaw into you actually compromise your first system. You can run code on it, arbitrary code. It's not the nicest UI, but it works fine. So this is basically bad enough, but this is normally where a real attack starts. Statistics from Microsoft says that after your first breach, it will take between 24 and 48 hours until you do an entire domain compromise of an internal domain today, when you have an advanced attacker in front of you. But we're going to show you some tricks, some stuff that we see in the wild and that we do during penetration tests, that you can take it from here.
Yes, because sometimes it's not so easy to get a nice UI and a nice interactive way of running commands on the system and then try to jump around and compromise the entire domain. Normally, in an average case, you should be able to make the system where you're running commands on connect to your own system out on the internet and set up what we call a reverse shell. So that will basically
Yeah, it would be nice if we do this attack, and then we make this internal JBoss server make a reverse connection to us that can hold a nicer UI for us as an attacker, if you will. This is what we want to achieve.
The problem is, in this case, and it's something not so uncommon, that certain servers cannot really connect to arbitrary locations on the internet. So you can't just trigger the server to connect to your attacker machine on an arbitrary port. If firewall configuration is properly done, that shouldn't be possible.
Yeah. Let's say there's no need for this JBoss server to connect to the internet. Maybe the firewall will block it here. But there will be other ways. Let's say, for example, that this JBoss is a DNS client that can talk to the internal DNS server and make requests that will be forwarded to the external server and then forwarded to any arbitrary DNS server on the internet. That could potentially be our server. So maybe we could use DNS traffic to tunnel remote control functions using DNS. And this is actually something that is getting more and more common in the wild, as one example. And also a technique we use in penetration testing when we are in high security environments.
So, using that technique, we will need a DNS server listening for DNS requests, which will be like real looking DNS requests. They will be actual DNS requests. Except then the server will do something else with it. So, an example of that is DNSCat. DNSCat has a server part, which will listen, and we'll have a client part.
And you can configure this in two different ways. You can configure it to go the real DNS way, which we do in normal cases. In this demo case, it will just be a DNS server listening to DNS traffic. So we will not care about the authoritative domains and stuff, just for demo purposes.
Yes.
But the traffic will still be DNS traffic.
So, then of course we need to run that special client on our target system. We can execute commands on that system, but the client is obviously not on that system yet. So we need to put it there. And that's the interface we have. So how do we put a file there?
Anyone could tell us how to do it? If you can, raise your hand. We're always looking for new people. No one here now. Okay. No one wants to tell us that they're
right.
into this stuff.
We want to transfer a binary to that system. We can't do it directly with a web request. But we can translate that binary file into text, send the text, and reconvert it on the other side. If you encode it the proper way, any data can be represented in text.
And on an internal Windows machine today, you can basically do anything using PowerShell, which in itself can use .NET framework and stuff, but there are also built-in tools.
Yes.
And since we have the PKI master Hassan here, he showed us years ago that you can use certutil for simple base64 encoding and decoding.
So if we have our DNS client, we can use certutil encode. We want to encode this file. Our DNS client exe, we want to base64 encode it and store it into a file name dns.base64. Which will look something like this. Then you can transfer this file, because it's text, it's much easier. And on the other side, you do reverse operation with the built-in certutil tool. So certutil-decode. And you get the executable back, and then you run it.
Assuming it's installed on the target, which it is by default in a modern Windows system.
So I have my file here, already base64 encoded. Looks like this. Now, how do I send file there? I can do something like this. I can echo a string into a file. Right? So let's go on the target side. This internal server, this is where I'm running commands now. This is the ctemp folder. So for my attacker, if I do this, this will create a test.txt file in ctemp and write test into it. Now remember, we're doing this through the XXC, and through the local proxy, through the XXC, through the JBoss shell all the time. No output. On the other side, we have the test.txt file with test in it. So we can write to files. We can write text to file. Now we want to write that base64 encoded file and decode it on the other side. So let's do it. We need to script this, right? Because it's a pretty long file, it's many lines. So we can use wget on a Linux system, for example. One of the main ways of doing this, which will make a web request, sending that command. And we can loop through each line of the file we want to send. For each line, we make a web request that we append it to the same file on the target. We need to URL encode it properly. I'm going to fast forward this part. This is a for loop that will basically do that. It will take each line of the base64 file, encode it properly. For each line, it will make a web request using the local proxy, because that's what's going to do the XXC attack. And the command will be echoing that line into a file in ctemp dns-client.base64.
And as you can see, there are so many steps that can go wrong. So it can be hard to assess these problems on your own, unless you work with this professionally. So it's easy to miss these problems if you don't know exactly what you're doing. I mean, normally when we do a pen test like this, we won't see the back end. We will just have to assume that what we do is right. If it doesn't, then try again.
So let's run this command. This will make a lot of requests, one per line. On the other side, this will gradually append everything on this file. And you can see the size is growing slowly. And this will look like this. So that's what we have on our attacker side. Now, this is a slow upload, so we can fast forward that. I have the file already here. So that's the complete file that we had on the attacker side. Still base64 encoded. So now we need to decode it. And we use the same thing. We can execute commands, so we just do the same thing, or the reverse thing that we did on our attacker machine. And we do assert util, decode, take the base64, put it into the executable. Done, decoded. Now on the other side, we have the executable. Now we have the DNS server listening. We just need to run the client. Ctemp DNS client. Now, as Marco mentioned, for demo purposes, we refer directly to our own server. So this will send DNS traffic directly from the target to our server. In a real case, you wouldn't have to specify this server. You would just specify the name of the domain, like evil.com or something.
And the target's own DNSs would look it up the normal way the DNS hierarchies work.
So let's do it. Check the server. New session established. Now the client connected to us through DNS. We can interact with that session. And from here, we can do several things. We can upload, download files, open new sessions, get a real command shell. This will spawn a new session, which we want to interact with. And that's an actual CMD shell on the system.
It's actually kind of funny, like if you're abroad and if you're in a hotel and you're not allowed browsing the internet without paying for it, but there's DNS lookup, you can set this up and you can remote or you can VPN using DNS and stuff and use free internet services on any hotel, as long as they allow for DNS. Because there's also DNS tunnels that can give you access to your own proxy or your own server back home.
And you can do exactly the same with ICMP, so ping. You can tunnel through ICMP.
We don't recommend that, of course, but still, I mean, it's
possible.
Food for thought. Like, this is what you can do. You can do anything over DNS channel as long as they don't inspect it and they get suspicious when there's a lot of data being transferred.
So, should we check how the traffic looks like on internal? I have Wireshark.
Sure.
It will be DNS traffic, so let's do some filtering. We'll just write DNS and apply the filter. So you can see this is just DNS traffic, and this one.
And now it says DNS cat. That is actually something that is defined that you can change. We want you guys to see this. So this is the DNS cat traffic. But of course, you could say anything here.
So now this is just keep alive messages that keep the session open. When you're actually transferring data, so if you do like task list on this system, which will transfer some more data, it will look like this. So this is the content of each DNS request. It's text that is placed as part of the host name of that DNS request to your own domain. And on the other side is going to be decoded and decrypted because it's encrypted by default. And well, then you have a certain special protocol to convert that into commands.
So this is one example of covered channels, the stuff that you have to deal with today.
All right. So now we have an interactive shell. Now we're in a pretty good position. It will be kind of slow to transfer files because you're doing everything through DNS request. So you need to take any piece of data, translate it into text, put it in the host name part of the DNS request, get the data back as DNS response. So it's very slow, but it's quite functional. So what can we do next? Can we compromise the domain? Internal domain? Is this machine even joined to the domain? It's not. We're internals in some kind of internal segment, but we are still not in the domain. But just because this machine is not in the domain doesn't mean that it doesn't contain domain-related sensitive information.
Yeah. So let's see what we can do. Again, what you usually look for, if you are on the system, either internally or in the DMZ, you will look for cached credentials, secrets, anything that can be used in order to access other resources. Sometimes they have shared passwords, so there's one admin pass on this server and the same admin pass on this one. Then you can use it to connect to that system, right? So this is a typical way. This is very typical if they're on the DMZ, because they're not joined to the domain, so it's kind of inconvenient. You don't have single sign-on, so they put the same admin password on them. Another thing that we see more and more, or use more and more, is that some of these DMZ machines could potentially be proxies for authentication. Let's say, for example, you're doing mobile access, or you're checking your emails on your mobile phones. Do you do that? That's like not a yes or no question anymore. It's like a yes or yes question. So if you have this single sign-on functionality, so you can authenticate somehow through the DMZ to an internal Exchange server, there may be, for example, simple authentication using basic authentication, which is not uncommon. So if a proxy server here is taking authentication traffic in order to be able to authenticate internally to an Exchange server, at some point in time, the usernames and passwords will be stored here, right? And if it's basic authentication, they will actually be in clear text. So a typical thing we do is we look for tasks that can have these credentials in memory. It can be a threat management gateway, ISO server, it can be some special equipment, something. It doesn't necessarily have to be email traffic either. It could be anything like web traffic, anything like single sign-on that's being proxied, any business application. So we're just going to show an example what this will look like.
So what kind of process we have on this system? We have an IIS server running web applications. So if that works in the way that Marcus just described, we might find credentials in the memory of that process. So we have this service, this process running, W3WP, that's the IIS worker. That's what's running one of the web applications.
World Wide Web worker process.
So we want to extract the memory of that process and try to extract credentials from it. So I have another couple of tools on that system that we can use, that we can potentially upload in the same way as we uploaded the DNS client, but now they're already there to make it simpler and faster. So we can use procdump, for example, to dump the memory of that file. Oh, that process, sorry. And store it somewhere.
Again, sitting on the internet, using this through the DNS tunnel.
It's a pretty big memory dump that we just got. Now we can use another tool called strings to just extract the readable characters from it, from this memory dump. And we're going to filter for basic authentication, which is a common way to authenticate in this type of scenario. And we will find all the authentication credentials that these users are authenticating with through this proxy, either for email or a Citrix or whatever. So if we stop this, this is just some, these are base64 credentials, base64 encoded credentials. So we can base64 decode one of them, the code as base64, and we will get the clear text, username, and password. And of course, we can use this to, now we can, we are running arbitrary commands on that system, so we can just reuse these credentials that connect to internal systems. If these are domain credentials, then we can connect to domain resources.
And this is standard practice for us when we do penetration testing. Almost any time we see a service like this, we will take the memory. And it's not very seldom that we actually see people running, even as domain admins, with that kind of accounts on their mobile phones to check their emails and stuff. So things like that, this is what you need to worry about. You need to think about your exposure credentials. And with the new world, when we have mobile phones and stuff, we bring them outside the company. And this is a typical way of exposing them. So you really need to think about exposure of your credentials. I mean, back in the days, you had your high priv accounts was inside the perimeter of that network. They're not anymore. Even the servers are outside the networks in the cloud nowadays. So the difference is pretty big. So, with these credentials, we could potentially access internal resources. I mean, we could impersonate any one of these people and steal their data. And if some of them is an admin of some sort, we can identify as him connecting to resources. So this was merely one advanced example. We're probably going to be able to do some more over the day if there's some extra time. But I think it's really important to be concerned about your web exposure. Also, when you throw up things in the cloud, there will be valuable assets there. If you have your new business application and stuff there, they need to be secure. And we've been doing client-side demos for a long time now. It's time to focus back on the server side. And again, this is merely one example. But you have seen some things in this demo that I think is very important. That some ways of getting into your networks may not be the obvious ones, like SQL injections. There could be other ones outside the OS of 10. There's one take-home. Another is the fact that attackers are now using encrypted methods in order to connect back home, and the DNS tunneling is one thing. It could be normal HTTPS traffic as well. So it will be very hard to detect using regular IDSs and IPSs. Also, attackers nowadays use public cloud services as attack platforms. So their attacker will not anymore be in China. It will actually be stored in Azure or Amazon Cloud or something. So you have to be proactive and have secure environments. Also, there will always be shells in order to maintain presence, but some of them will only run in RAM. So you have to be very careful about just looking through hard drives when you're trying to find stuff. You actually have to look in memory too if you suspect something to happen. And it could mean that you should not turn off a computer if you want to do an investigation. So there are a lot of new things you need to think about. But we will talk about those things in the upcoming sessions. So I think it's time for a break. So I'm going to leave it to Mats.
Yeah, thank you guys. Applause.
And I don't know if you know how hard it is to do all these live demos without failing. So an extra thank you, Fabio, for doing this so great. Thank you, man.
Thank you.
And Fabio, where can people find you on the net? Are you on Twitter? Are you blogging somewhere, something like that?
Yes, I'm on Twitter, on Fabio_Viggiani, and email is fabio@trusa.se if you need to contact me.
Yeah, cool. And Marcus?
Marcus@trusa.se.
Easiest
That's
way.
where you find me. You can find me on other places as well. But.
Oh, thank you guys.